Let's go through list code 41. Find the missing, first missing positive. And for this question, it gives us an integer array nums. Let's find the first missing positive integer. For example, 0, 1, 2. So the first missing one is 3. We have 1 and 2, right? So the first missing one should be 3. And the second question, second example, we have 1, but 2 is not here. And we have 3 and 4, right? And the third one is you will see we don't have 1, right? So the first missing one is 1. So what are we thinking about for this question? For this question, it have a nums range to be 10 to the power 5s, and also a length range, right? And also nums range is the whole integer. Actually, this question asks us to do this in O(n) time in the O1 space, constant space. Actually, so what we're thinking about is that because we are trying to find the first missing positive, the first missing positive can only be in the range of 1 to n plus 1, right? Yeah. So the things that, for example, if we have these nums, there are n number in it, right? So the length is n. So the first missing one can only be from 1 to n plus 1, right? The optimal way, I say, if all of this number, they are from 1 to n, then what we need return is n plus 1, right? So what we're thinking about is that for these numbers, if they are in a range 1 to n, right? Then, we'll see, for this kind of nums, the length is n. 1 to n, there are also n numbers, right? So we can have every number have a corresponding positions in this num if they are in this range. So we'll see if they are in range 1 to n, we have index to be 0 to be n minus 1, right? So what we do is that for the numbers in this range, we check if this number is, how can we do that? And we put this kind of index, we'll see every position, right? To be some kind of special flag, right? So if we don't want to change the use actual space, how can we do this flag? The first thing is that we should set every number out of this range, for example, smaller equal to 0, right? Or every number greater than n to be a number which is outside of this range, right? So what we do is that we set every negative one to be, for example, n plus 2, okay? This question is not that good because it the negative have this kind of range, right? So if, for example, if the negative, for example, it is smaller than 2 to the 30 or whatever, right? Minus is greater than this, right? We can have all of the negative shift to a positive range, right? And for example, this is smaller than this, some kind of number. We have a range greater than this, so that we can restore the original number. But for this one, if it asks us to use O1 space complexity and ON time, right? If you give us this kind of time range, it's hard for us to restore. But if, for example, give us 10 to the 5 minus or 10 to the power 5, right? We just have this one shift to be outside this range, right? And then after we do manipulations, we just have shift back. But this range, we cannot restore the original one. So we first do the pre-processing for every negative number or to 0, right? Not only negative, because we are not looking 0 either. Put all of these numbers minus infinity to not minus integer max minimal, right? Minimal to 0 to be n plus 2, right? So that we get all of these nums to be positive. And then what we do is that we for the nums in the range 1 to n, right? And we get its index, and we check. Actually, do we need to check? Oh yeah, we need to check. We need to check if the nums index, if it is greater than 0, right? Then we set this one as a negative one, right? Multiple by -1. If it is already a negative, for example, some of the number appears several times, right? We just set this one as once. So we have this one greater than 0, so that we set from the index 0 to n minus 1, right? So if they appears, they will be negative. Right? Then the next step is that we iterate from the nums, right? After we processing, if we find in this range, for example, index, it's not negative, right? So that means there is one number in this range missing, right? Then we just return this index plus 1. If all of these numbers, they are negative, right? Means we have n to n, 1 to n, they are all in our integer array. Then we just return n plus 1, right? So after doing this analysis, let's just write code. And int n equals nums dot length. And I would say this condition is not that good because we are not able to restore, right? So if we want to restore, we should get the range smaller to something like this, right? Or something like this. So we're still using ON and O1 space, ON time and O1 space. So what we do is that so first thing is that if this number is smaller than equal to 0, right? For int I 0, I smaller than n, I plus plus. If nums I smaller equal to 0, then we just have nums I equals n plus 2, okay? Actually, this number you can put anything, right? And because when we iterate this nums, we need to check its range. That would means it's just not in our range, but we need to process this to be a positives. Then what we do is that for int I equals 0, I smaller than n, I plus plus, and let's have int index equals math.absolute value nums I minus 1, right? So that we use the every n, right? So what we do is that if this index smaller than n and nums index greater than 0, right? Then we put a negative here. Nums I multiplied by equals minus 1, right? And we just need to check, right? So what we just need to check for int I equals to 0, I smaller than n, I plus plus. If nums I greater than 0, right? That means we need to return I plus 1. And in the end, that means we find from 1 to n. Then we just return n plus 1, right? This should be nums index, sorry, index multiplied by. For this time, this range, we are not able to restore it. And let's change this code to Python. So we'll say n equals length nums, right? Let's say for I in range n, okay. If for nums I smaller equal to 0, right? Just have nums I equals n plus 2, okay? If we can, if it is in a smaller range, right, we just shift it to a range which is so that we can shift back. And then let's say for I in range and let's say index equals absolute nums I minus 1, right? So I say if this index smaller than n, and nums index greater than 0, right? Then we set it as a negative. Because we just need to set this one once, right? Because it may be repeating. If we set a negative and then we can also say, so yeah, so to be a minus absolute value, right? So it is we just because we have conditions and, right? So we just have index multiple equal to -1, right? And then we check for I in range, and if nums are, if it's missing, right? Then we'll say because this num already we minus it, right? So we just return I +1. And in the end, that means every 1 to n is fine. Then we return n +1, right?